Then we move forward to pillar number 2, Fernando, and then by the end we will have time for questions. Fernando, the floor is yours.
Yes, thank you so much. It's a pleasure to present this pillar, and I want to also thank the previous colleagues that with the presentation helps to contextualize what we are going to present and what we are going to pursue in our pillar here. Okay. Yes. So this is what we have already have discussed the spread of the Spodoptera frugiperda. As you can see, from since 2016, when was the first time that was detected in Africa continent, west part of the continent, the spread was very fast within a time frame of 10 years. And now we can see that we already detect in some parts of Europe. This is the reason that we are talking here and we are meeting each other, is to try to avoid or understand and be prepared for the Spodoptera frugiperda when arrives in the European continent. No. Okay, in this slide, I like to present it because this complex ecosystem has all the elements that we are going to address in our pillar. This perfume language that we can find in nature can inspire the way that we are going to address some of the problems or some of the questions that we are going to answer. So in the next slide, we are going to pretty much focus our attention is in the part of the pheromone, the insect language to communicate between them. We have already seen some of the uses of the pheromone that we can have as a monitoring that we are going to discuss in the next slide. But we also have the possibility to use the pheromone in mass trapping or in mate disruption, as our first speaker presented. There are good results using the mate disruption technology. No, but as we are interested very much in monitoring, so we are going to focus in the first way to use this technology. No, where we can rely on these 4 compounds that was since the beginning. Was as our colleague from Greece mentioned it, that all the pheromones, or pretty much almost all the pheromones, are using these 4 compounds that have been detected a long time ago. The problem that we are seeing, as he pointed out in his presentation, is the lack of selectivity. We have a lot of side catches and different species, what makes this noise, so we can define, which complicates to understand how the Spodoptera frugiperda is behaving. No, and so the pheromone is not one size fits all. No, so we need to improve the efficiency and also check if the region it's a region specific problem as well. So depending of the lure or depending of the traps, we can have a lot of problems, noise. And as we can see here, in certain regions, it's interesting to check in the pheromone gland if there are new compounds that can help us to improve the efficiency of the pheromone lure, and also, of course, prepare a product that it's specific for each region. As we can see in Brazil, we have they found a specific compound. Then later on in Japan and also in US, they found a new compound that improved the efficiency of the pheromone. So in task 4.2, Benaki, our partner, is the one that will be responsible to analyze the gland pheromone from the Spodoptera frugiperda from other regions from Europe, no? So the Greek Spodoptera, the Spanish Spodoptera, and see if we can find a specific compound that we can improve and prepare a custom-made pheromone for improving the detection, no? Or avoiding this noise. Okay, so this what we can see here as the pheromone. Like the pheromone, there are no one-size-fits-all trap. In the literature, in the scientific literature, we can find a lot of articles concerning about which one is the best trap for monitoring the Spodoptera frugiperda. And this is something that we are also planning to give the answer, no? To check for each region of Europe, which one is the best trap, the best combo, no? I would say which is the best lure and which is the best trap that we can use in our specific regions. The problem of this with the traps, I can say, is that is the maintenance, no? As we can imagine, that like our Greek partner mentioned, or the colleague, that they have to visit and also check if the trap every 10 days. So it's a lot of work. And this is what helps me to go to the next slide. Of course, with the new technologies, the idea is to avoid or to, let's say, facilitate, no? this maintenance. And now there are a lot of automatic traps out there, which promising that it's good and help to minimize the time and also give the information in real time. So our idea here in the project, it's pretty much use this technology, but using a different model. The idea here is to avoid, no? This model is thought with the idea to reduce the maintenance time, no? Basically, it's a CD. I would say it's like a CD player that we can change the stick. Each disc is on a stick surface, and then once the stick surface is completely full, you can easily change by just remotely change the CD. So this is what we are so far. We are already checking this technology if it's worth to pursue. So we have sent some of our partners that was responsible to monitor the Spodoptera. They have already this trap model and check if it's possible to monitor and see the efficiency of this technology. No, this is in the task 4.1, which ECOBERTURA is the responsible for this work packet, this task. And of course, once we have picture, now with the AI and all the machine learning, we can take advantage of this picture and help us to develop our recognition algorithm that will facilitate the counting and also the recognition. So this pretty much make all the process as much automatic as possible, no? So this is in task 4.3 that is responsible to develop a new recognition algorithm for our Spodoptera frugiperda. And then we move to the other part. No, we're talking first of the perfume language of the insect, and now we are going to talk about the perfume language from the plant. When it's under biotic stress, it's known that the plant release some volatiles, and these volatiles can be useful as a fingerprint, no, to help to understand when we have the Spodoptera frugiperda is attacking our crop. So this is something that we can also take advantage. And our partner from Switzerland, the University of Neuchâtel, is responsible to develop this technology using different sensors. Here, what I'm showing in my slide is in this part here, the slide. They are testing 3 different sensors in order to check which one is the best and more suitable to identify or to collect these volatiles in laboratory conditions and also in field conditions. Of course, these volatiles also is very important to understand when the crop is being attacked and also when the natural enemies can identify also in an attack the Spodoptera, no? The caterpillar. This is in task 4.6. And the ultimate goal of this task is once they develop this sensor and understand the odor profile, no? It's place this sensor in a rover that is possible to move through the field, collecting these volatiles and then using this specific fingerprint, other fingerprint, can provide information if the crop has or doesn't the presence of Fall Armyworm. As we have discussed already, the problem, of course, when the farmer needs to treat its crop with a pesticide or insecticide, the problem that we can find is that the Spodoptera or the organism has resistance. And the idea of this task here is to develop a tool that can facilitate to understand based on the genetic markers if the Spodoptera that is in the field is resistant to a specific pesticide. So this is task 4.5, and the team responsible to develop this technology, that can be useful in real time in the field is FORTH, it's a Greek institution. No? Finally, with all this information that we are going to gather in generating this work package, and here is to also take advantage of the information of work package 3 and prepare a monitoring protocol tailored to each region of Europe. So then with all this information, we will be able to say that in which region, which is the best way to monitor and to follow a specific protocol that will give the answer, if the Spodoptera is present or not. This is task 4.4, and this is Indra, is our colleague that will be responsible to develop this task. As a summary, our work package 4, which is the detection part, is made of 6 tasks, and the tasks that I have talking during my presentation here. So thank you for your attention, and I'm willing to answer any question that you might have.